So today we want to finish solving equations with rational expressions, and we want to expand it so that we're not just dealing with proportions, one rational expression equal to another rational expression, and how we do manage to get rid of all of the rational expressions, because we discussed you can't solve for a variable if the variable's in the denominator. So to solve an equation with a rational expression in it, your ultimate goal is to get rid of the rational expression. And we discussed that to get rid of rational expressions, we have to multiply by the LCM, least common multiple is what LCM stands for in case you've forgotten, multiply by the LCM of the denominators. Now, in the past, you may have been told by another teacher that to get rid of fractions, just multiply by the denominators. Whatever the denominators are, just multiply by all of them. And that is always going to work. It will always get rid of the rational expressions. It will always get rid of the fractions. The problem is sometimes it gives you bigger equations to solve than you really want to deal with. At least if we always use the least common multiple, then we're always going to get the smallest version of that equation that we need to solve, which always makes it easier. It's much easier to deal with x squared than it is x to the fourth or x cubed. So we do tend to want to use the LCM because that way we're dealing with smaller numbers and smaller things to solve for. So let's look at some examples. So if I have n minus 2 over n squared plus 6n is equal to 1 over n minus 1 over n plus 6. So this is our equation that we want to solve. Notice that it is not just one rational expression equal to one rational expression. We have this minus and another rational expression out here, so we cannot just cross multiply. That's not a method. Remember, all cross multiplication is multiplying by the LCM of the denominators. So what we want to figure out is what is the LCM of our denominators. So we know that in order to find LCM, the first thing we want to do is factor. So factor first. That's going to help us make sure that we actually find the least common multiple. So this is going to have a common factor of n. So this will be n times n plus 6. This is as factored as it's going to get, and that's as factored as it's going to get. So if I look at my monomials, n is the only monomial, and its highest power is just 1. The only binomials I have are n plus 6, and the highest power it has is 1. So this looks like my LCM is going to be n times n plus 6. What we have to make sure we do is distribute and multiply everything by n plus 6. This means that we're not changing the equation. It's getting multiplied on both sides. It's getting distributed, and it actually doesn't change the value of our equation. But we want to make sure that everything gets multiplied by that LCM. And then what happens here is the n's will cancel out, and the n plus 6's will cancel out, and all I'm left with on this side is n minus 2, what was in the numerator right here. On this side, my n does cancel out, but I do still have n plus 6, so I need to make sure that I multiply 1 times n plus 6, and I just get n plus 6. And then over here, my n plus 6 is going to cancel out, but I do have negative 1 and n left over. So I want to make sure I don't lose this minus sign. A lot of students lose this minus sign. So if you want to keep yourself safe, I change it to plus a negative so that the negative stays with the number and I don't accidentally overlook the minus sign. And then negative 1 times n is negative n. No longer are there any rational expressions. When we multiply by the LCM, the reason we use this number is because the denominators will always have something to cancel out with. And so all the denominators go away, and we're left with some kind of polynomial equation that we can deal with. So here I notice n minus n, well, that just goes away. So if I add 2 to both sides, I get n is equal to 8. And as we discussed yesterday with proportions, we always want to check for extraneous solutions because these did have rational expressions. There were some numbers that n could not be. N is not allowed to be 0 or -6, but 8 is neither of those numbers, so it's just fine, and we should be able to move on. Another example would be a problem like 1 over n squared minus 3n is equal to 5 over n squared minus 3n plus 2. So this is not a proportion. I have one rational expression equal to one rational expression, but something's being added to this rational expression. It's not another rational expression, but it's not a single rational expression. So I can't cross multiply. That's not something that would work. We do want to remember adding a whole number. Whole numbers can always be written as a rational expression if we just write them over 1. So we do have a fraction to work with here. And we still want to multiply by the LCM of the denominators. Well, we got lucky. We have one denominator that's 1, and the other two denominators are exactly the same. So I'm not even going to bother to factor these out because they have the same denominator. I know that's going to be the least common multiple. So I'm going to multiply all of these by n squared minus 3n, n squared minus 3n, and it helps to put binomials and trinomials in parentheses just to make sure that you don't forget to distribute things. That's the biggest mistake here, so we want to make sure that we don't forget to distribute. But here, n squared minus 3n cancels, so I'm just 1. Here, n squared minus 3n cancels, and I just have 5. But here I do need to remember to multiply by 2. I do need to distribute that. So this is going to be 2n squared minus 6n, and that is a quadratic. And as we mentioned, we always are going to get rid of the denominators when we multiply by the LCM, but we're always left with some kind of polynomial. This one is a quadratic, so I know quadratics have to be equal to 0. So I'm going to subtract 1 from both sides, and I get 2n squared minus 6n plus 4. And then I notice that these are all even numbers. So I can at least divide everything in the equation by 2, because that's just going to give me smaller numbers. So 0 is equal to n squared minus 3n plus 2. And I'm going to try and solve by factoring. So two numbers that multiply to equal positive 2 and add to equal negative 3 is going to be negative 2 and negative 1. And so I get that n is equal to 2 and n is equal to 1. Now we have to be careful and check for extraneous solutions. We want to make sure that none of the restricted numbers, so here n could not be 0 and n could not be 3, because that would give me 0 in the denominator, and neither one of these are 0 or 3. So we are good to go. They're not one of the restricted numbers. One more example. 5k minus 15 over 3k plus 5 over 3k minus 6 is equal to 5 over 3. So again, not a proportion. There's more than just fraction equal to a fraction. So I'm going to have to find the LCM of my denominators. So I have a monomial. This will factor 3 times k minus 2 and 3. So when I look at my monomials, I got 3k, 3, and 3. So the LCM of 3 is just 3. And we do have a variable k in the monomial, and its highest power is just 1. So 3k is the monomial part. We only have one binomial, and its highest power is 1. So it looks like our LCM is going to be 3k, k minus 2. So that's what we want to multiply everything by. So 3k, k minus 2 times 3k, k minus 2 times 3k, k minus 2. All right, so if I'm looking at my denominators, here I'm going to get 3 to cancel and k to cancel. So I end up with k minus 2 times 5k minus 15. I'll multiply that out in a second, because don't forget, if I have a binomial times a binomial, I do have to double distribute or use your area model. So I'm going to hold on to that for a second. Here I'm going to get my 3 to cancel and my k minus 2 to cancel, but I've still got a k. So 5 times k is 5k. And over here, my 3 is going to cancel, but I'm left with 5k and k minus 2. So I do need to clean up a little bit. I have gotten rid of my denominators, though. I'm down to some kind of polynomial, so let's multiply this out and see what we end up with. So this is going to be 5k squared minus 25k plus 30. So when I did my double distribution, that's my trinomial. I have the plus 5k still. And then here I do need to distribute 5k, so I get 5k squared minus 10k. So it looks like it's a quadratic, and I know quadratics need to be equal to 0, but if I subtract 5k squared from both sides, look at this loveliness that happens here. My 5k squareds cancel out. So I thought I was going to have to solve a quadratic, but it actually turned out to just be linear. So yay for that. Negative 25k plus 5k would be negative 20k. And then I have plus 30 is equal to negative 10k. And then we have, let's see, if I add 20k to both sides, I get that 30 is equal to 10k, and when I divide by 10, I get that k is equal to 3. So this gives me k is equal to 3. Now I need to double check. I have to check for those extraneous solutions. You're not guaranteed you're ever going to have an extraneous solution, but you always have to check. It is always possible. So I look, and 3 was not one of the restricted numbers. K couldn't be 0 and k couldn't be 2. So it's not extraneous, and so I can use that as one of my numbers. So we're going to do one more example. 3 over v plus 3 minus 1 over v plus 3 is equal to 2v squared plus 16v plus 24 all over v squared plus 3v. So again, not a proportion. We need to figure out what our LCM is going to be. So this is already factored, and this is already factored. This has a common factor. It's v times v plus 3. So looking at my 3 denominators, I have one monomial. So I got to keep my monomial. And we only have one binomial, and that's v plus 3. So it looks like this is going to be our LCM. So we need to multiply everything times v plus 3, v plus 3, and v plus 3. So on this side, I get my v's to cancel out and my v plus 3 to cancel out. So I'm just left with the quadratic on the top here. And then over here, I get my v plus 3's to cancel, but I still have a v. So I want to make sure I do my 3 times v. And here my v plus 3's will come out, but I do have negative 1. So again, I have that minus. So I want to make sure this stays with the 1. This is negative 1 times v. So this will be negative 1v. So 3v minus 1v is 2v, is equal to 2v squared plus 16v plus 24. It's quadratic, so I do need to get it equal to 0. I'm going to subtract 2v from both sides. So I get 2v squared plus 14v plus 24. I notice they're all even, so I can divide everything by 2. So I get 0 equals v squared plus 7v plus 12. And two numbers that multiply to equal positive 12 and add to equal positive 7 are 4 and 3. So it did factor. And I get v is equal to negative 4 and v is equal to negative 3. So we should always check and see if any of these numbers won't work. And what I notice is that v is not allowed to be 0 and v is not allowed to equal negative 3. So this is one of the restricted numbers. This is going to be extraneous. Please make sure that you realize if something is extraneous, it is not a solution. So on something like IXL, if you're writing the solutions or putting the solutions in, that's not going to be included. You're not going to put that as an answer. It's not like, oh, I'm going to put it as an answer and just say it's extraneous. No, it's not an answer. The only solution that actually works is negative 4. And so this would be the only answer that you would want to put for that because this one was